All right, here we go. So I'm going to be filming this, if that's okay with everybody. I hope you don't mind. I made a documentary about Bufo Alvarius in 2017, and there were a number of mistakes in it that I feel bad about and I want to correct. So in the new season of my show, I'm dedicating an entire episode to mistakes and correcting them. And in this presentation, I'll address a couple of the mistakes. Oh. All right. Give it up for making mistakes. Okay. But yeah, so I hope that I can address a couple of the mistakes and ways to avoid these sorts of mistakes in the future. One of the most amazing things about watching this conference over the last couple of days has been how much discussion there is about best practices or abuse or the spirituality, and how little is actually known about this substance that everyone is here gathered to talk about. There's almost nothing known about it. Until April of this year, the previous published analysis was from 1965. I mean, there is almost nothing. Dr. Jerry published a little tiny thing in one of his books, but for the most part, this substance is a chemical unknown, and even that analysis from the 1960s wasn't actually on the expressed secretion from the gland. It was on total extraction of the toad's skin, or on the excised gland that had been homogenized and extracted with acetone. So, okay, I'm going to review. I actually can't see the presentation, which is unfortunate, but I'm going to review a couple of salient details about the prehistory of 5-MeO-DMT. So, like DMT, 5-MeO-DMT was first discovered synthetically before it was ever found in nature. There was a Canadian natural product. There was a Canadian natural product chemist named Richard Helmuth Mansky who first synthesized DMT in an effort to create references for potential natural products, but he never actually found it in nature. And the closest thing that was known to exist was bufotenine, which had been isolated from the extract of the common European toad Bufo bufo during World War I. And that in and of itself was pretty amazing, to extract a crystalline substance from a toad that was known to have this sort of biological activity, but at that time, neuroscience didn't exist in any capacity relative to the way it exists today. I mean, they were aware that it could accelerate heart rate and things like that, but they didn't know that it was a psychedelic. They didn't know that it really did anything in the brain, and they weren't looking. So it was more of a chemical oddity than anything else. But it still inspired new generations of chemists. So you had, in Japan, you had a group of two chemists who were synthesizing derivatives of bufotenine. They made the methyl ether of bufotenine, which is 5-MeO-DMT, that was partially inspired by the work of Mansky in Canada, and also because it bore a structural resemblance to a compound called physostigmine, kind of, and they were interested in that resemblance. Then it was found in nature. It was found in a Dictyoloma species, and the concentration was so low that it wasn't really that notable. I mean, it was less than 0.1%. And then that was kind of it for a little while. In terms of indigenous use, there's a separate timeline, and people will, debate endlessly what was done where and when, but due to the lack of a written record in many of these cultures, it becomes very difficult to say with any degree of certainty what truly happened. And when it comes to these plant preparations, what you can say is that it wasn't pure 5-MeO-DMT. It was typically a combination of 5-MeO-DMT, DMT, bufotenine, and other things. And a notable example would be a discovery that was made earlier this year of an interesting, is this on the screen? Yes, it's an interesting pouch made out of 3 stitched together fox snouts. And it was found to contain DMT, bufotenine, and 5-MeO-DMT that was thought to come from some kind of Anadenanthera type seed, although they didn't definitively identify that. Okay. So So the human use of 5-MeO-DMT containing plants can be dated back maybe 1,000 years, but it wasn't isolated material. It was a combination of different things. The real breakthrough in 5-MeO-DMT research was made by an Italian chemist named Vittorio Erspamer. And Erspamer is best known for having discovered serotonin. He didn't name it, he called it enteramine, but he was very interested in finding serotonin-like molecules in nature. And his methods were pretty brutal by today's standards. When he was trying to isolate serotonin, initially, I believe he used 30,000 pairs of salivary glands from octopuses. So they were using absolutely enormous amounts of biological material to isolate these substances. And when it came to toads, he had that same sort of methodology, which was really great in a certain sense, because he was able to very carefully profile the chemical composition of the toad secretion. But again, as I said earlier, he wasn't expressing the venom in the way that it's done today. He was cutting the entire gland out of the dead toad. And for that reason, I don't think that his numbers are necessarily relevant, or they have to be qualified as not being the same. And I think the major difference that you'll find is that the bufotenine concentrations are much higher. So here, let me go here. So I wish I could see this, but as in the total skin of the toad, the ratio of bufotenine to 5-MeO-DMT, it's still more 5-MeO-DMT, but there's a substantial quantity of bufotenine. When you transition into the excised gland, it's only a trace quantity of bufotenine. And when it comes to the analysis of the expressed secretion, at least in terms of my own analysis from 3 different samples, one was a reference sample from Sigma Aldrich of the Colorado River toad, and 2 of the other samples were collected in different locations in Sonora some years ago. There was no bufotenine whatsoever detected, and the analytical technique here is called ASAP-MS. It's a very sensitive technique. It may appear that there are many different components, but it's a bit tricky because even a single compound will provide many peaks because it fragments in the mass spectrometer. So I can't say with certainty how many different things were there, but 5-MeO-DMT was present, serotonin O-sulfate was present in both samples, and one of the samples contained an interesting compound called bufoviridine, which is could also be called bufotenine O-sulfate. This is non-quantitative, so it doesn't say anything about the actual concentrations of these compounds, just that they were there, and I think it's interesting that bufotenine was not detected. So that was pretty much it. There's the Erspamer work, there's this unpublished stuff that I did a little while ago, and then in April of this year, a new paper came out that's really fascinating. It was published in Psychopharmacology. It's not actually a chemistry paper. It's really more about the human response to 5-MeO-DMT, but it included this analytical section that's pretty mind-blowing. It's almost so weird that I'm a tad skeptical, but they found DMT in the secretion, which has never been detected previously, as well as DET, which has never been found in nature, period. And I'm kind of surprised they were even looking for something like that, because it's not the sort of thing you would expect. And I would like to see these results replicated, because they're pretty extraordinary. But there's a few takeaways from this research and from the Erspamer research from the 1960s. And one of the major ones is you can actually see that there's a tremendous amount of variation in the concentration of 5-MeO-DMT. In the more recent work from 2019, there's about a 50% increase from the lowest potency sample to the highest. With the Erspamer research, it's a 300% increase. And I think this really is important to acknowledge, because I've heard some people complain about people eyeballing the dose of the medicine at these ceremonies. Well, you can weigh it on the most accurate precision balance in the world, but it won't matter if there's tremendous variation between the samples that you give people. And this is really, this is not an insubstantial difference. I mean, this is a difference between, assuming a 100 milligram dose, I think it goes from, I have it written on the slide, but I think it's the difference between 20 milligrams and 30 milligrams of 5-MeO-DMT. So, and that's less than would be expected from the previous analysis that was done in the 60s. So there could be tremendous variation, and it hasn't even been looked at, really. But I think that that's something that has to be acknowledged. In the 1980s, there was an amazing character who I'm going to talk about a little bit more named Albert Most, or that was his pseudonym. And he, I think, predicted some of these problems and suggested homogenizing the extract to reduce that variability. That's one technique, but I think that this is something that needs to be really seriously considered and is one of many advantages that synthetic material has over the natural product. Okay. So this is just getting into the actual structure of the gland, what we're talking about. There's a lot of debate about what to call this stuff, whether it's a secretion, a poison, bufotoxin, venom. I prefer the term venom because that has been the chosen term of most of the people that have seriously examined the microscopic structures of the gland. Additionally, it does sort of behave like a venom. You know, it squirts from specialized pores in response to stress or threats. But this is a nice illustration that a herpetologist sent me that shows a dissected gland, and you can see the pore where the venom escapes, as well as the lobules that compose the gland in cross-section. Okay. And here's a little bit more, sort of like a powers of 10 with the Bufo Alvarius gland. You can see the different levels of magnification. The person that did this research, I think, did an absolutely, he's another one of these guys who did this work decades ago that no one has followed up on. I called him on the phone to ask him if he had done any subsequent research on Bufo Alvarius, and he hung up on me. So I don't know if maybe he gets a lot of calls, but I kind of doubt it. I don't know. Maybe he just didn't like me. Okay. So, yes, this is a sad photo. So there's a lot of talk, a lot of very well-intentioned discussion about how best to milk these toads. And, you know, I think that a lot of the things that I've heard are definitely good. You don't want to load a huge number of toads together in a single container where they might be able to transfer fungal infections to one another. You don't want to stress them out unnecessarily. You don't want to milk them too frequently. But the reality is that they are facing so many different threats simultaneously that it's hard to even say what is responsible for what. It's this really kind of tragic situation. If you go to Sonora, you see that we've created all of these roads. The roads have artificial lights. The toads congregate around the artificial lights because the lights attract insects for them to feed on, but then they get hit by cars constantly because they're on the road. It also makes it easier for humans to catch them, and it probably exposes them to other sorts of human pollution. I mean, there's issues with climate change, there's issues with habitat destruction, there's issues with pesticide contamination. There's a lot of different problems that they're facing, and for that reason, I feel very strongly that the best conservation tactic would be to use synthetic material and, yeah, I guess someone agrees, that's good. Use synthetic material and dedicate any resources that you have to just preserving their habitat or protecting them, because I don't think there is a good, sustainable way to milk these toads, especially if this material keeps gaining popularity at the rate that it is. Okay, let's see here. So I'm going to talk a little bit about that. Okay, so here's the big question now is this kind of, it really boils down to a spiritual argument, I think, is can this be replaced synthetically? There are arguments that there are a number of different compounds that have been isolated from Bufo alvarius, and they all may contribute to the effect of the venom in the same way that people talk about the different cannabinoids and terpenes creating an entourage effect that modulates the activity of smoked cannabis. And I think that's possible, but there's no evidence for it. And I think it's really important to think about this in an evidence-based way, because it has a huge implication for conservation. The same thing happens with other rare plants like peyote. People will say, oh, well, peyote has these different alkaloids that modulate the experience or enhance it in one way or another, like peyote, thus we need to use peyote. We can't use San Pedro. We can't use synthetic mescaline. Well, if that is truly the case, why is nobody synthesizing peyote to figure out whether that is really a contributor? Why not actually test these things? Why, if it's so important, then do the work and figure out if they're really contributing. I think that they're probably not contributing all that much, because even bufotenine, which is the only other compound that has ever been found in Bufo alvarius that is definitively a psychedelic, is never present in very high concentrations, if at all. It wasn't present in any of the analyses that I did. And it's a much weaker psychedelic than 5-MeO-DMT. So it would be like if you made a sauce that was like a bucket of habanero peppers, and then you put one basil leaf in it, and you said, oh, well, the basil really contributes, it plays a big role. I mean, maybe, probably not a major effect. I mean, 5-MeO-DMT is very much active at 5 to 10 milligrams. Bufotenine requires tens of milligrams. The effect is different, it's longer lasting, it's more nauseating. I don't think that it plays a major role in the experience that everyone is collected here to talk about. Although bufotenine is interesting and is worthy of evaluation. So the first question is, what is in this stuff? Let's analyze it, which I think is really kind of the only justifiable reason for milking toads right now, is to analyze the venom, figure out exactly what it contains, figure out how it changes seasonally, and then figure out a sustainable synthetic way to recreate it so that we don't need to bother toads. And luckily, it's really easy to do that. When 5-MeO-DMT was first synthesized in the 1930s, the chemistry was really difficult. It was maybe a 7-step synthesis. There was no way to do that on a large scale. Now, due to the globalization of the chemical trade, you can get the precursors to make 5-MeO-DMT, which are completely legal internationally. It's 5-methoxytryptamine is a metabolite of melatonin, for 30 cents a gram, something like that, and produce it very inexpensively synthetically on as large a scale as you want, and that's that. It doesn't have to involve toads at all. So I wanted to actually present the synthesis here, but legally it was very difficult to find a lab in Mexico, even though 5-MeO-DMT is not an explicitly controlled compound. A lot of people were sort of reluctant to let me demonstrate, to present here. Yeah, so, but I will do it eventually. And it really boils down to this question of what is a derivative, which is not a chemically meaningful term. So it boils down to the biases of whoever the authority figure is. Is 5-MeO-DMT a derivative of DMT? Well, if you're going to say it's a derivative of anything, it's a derivative of bufotenine, but no one ever says that because they're just concerned with the name, that it contains DMT in its name. So it's a tricky situation, but there is another way. With something like ibogaine, it's complicated. You pretty much do need to get it from plants in order to provide it to people. This is a lucky situation where it doesn't need to come from nature. There's a way to do it sustainably, and I think we should really seriously consider this. And these are just a few other examples of what happens. I think we're all aware of what happens when an animal becomes important in our medical practices. It's almost always disastrous. It never ends well. Whether it's milking hemocyanin from horseshoe crabs, or I actually don't know exactly how damaging it's been to scrape the secretions of Phylomedusa bicolor, but I can't imagine it's been good. Or a really tragic example would be this thing called the scrotum frog that lives in Lake Titicaca, that was just one of these things like rhinoceros horn, where someone just decided that it has medicinal properties when it doesn't at all, and people are using it in this drink called Rana Imaka, and it's decimated the wild population. So if that can happen with something that doesn't even do anything, imagine what can happen with something that pretty reliably produces a religious experience in everybody that uses it. Okay. So I gave you some of the early 20th century history, which is not really relevant to this Congress. What's really important is the human history of 5-MeO-DMT. So there was, in the early 70s, there was a little bit of use of synthetic 5-MeO-DMT, but it remained pretty obscure until the publication of a very beautiful and influential pamphlet that was authored under the pseudonym Albert Most. And this pamphlet, it really told you everything that you would need to know to do this. It came out of nowhere. It told you how to milk the toad, how best to administer it, what dose was appropriate, and it put this strange practice on the map in a way that it simply didn't exist previously. I became obsessed with this pamphlet because I felt that it was really vital to understanding the history of 5-MeO-DMT. Whoever wrote this is the person that invented this practice, as far as I'm concerned, as far as the written history is concerned. And I dedicated a huge portion of my episode about 5-MeO-DMT to figuring out who this person was. But bizarrely, there were a series of imposters who had taken on the Albert Most identity and were misrepresenting themselves as Albert Most. So I had to weed through this series of toad venom imposters and still stumbled upon the wrong person. So at first there was this guy named, I believe, Robert Burns, who had sort of digitized the pamphlet, put it online, and had taken on this identity. But he wasn't the real one. Then there was this guy, Alfred Savinelli, who's an interesting figure because I'm sure there's a couple people here who know who he is. He is actually like a figure in the psychedelic community, and his story was corroborated by two people that I trust, and he had certain similarities with the real Albert Most. He was a participant in Rick Strassman's famous DMT studies in New Mexico. So I thought, what are the chances that someone whose story is corroborated by people I trust, Trout, namely, if anyone knows who that is, who is also a participant in Rick Strassman's studies, who claims to have done it. Why would anyone lie about that? It's so bizarre. But he did. He lied about it. It's just a really unbelievable coincidence. So I made a documentary about how he was the first person to do this, and I was completely wrong. I made a mistake. I didn't expect someone to lie about having done it. But one of the really interesting things that came out of this is after it aired, I got a very polite email from a lawyer who said, I really like what you did, and I'm not trying to give you a hard time, but I have to inform you that you made a mistake, that the person who identified himself as Albert Most is an imposter, and I know this because I was friends with the real Albert Most. And then she sends me a number of original T-shirts and pamphlets to prove that she knew him. And I thought, wow, that's pretty interesting. Then another person came forward and said the same name, said his name was Ken, that he lived in Denton, that they were sure he was the real guy. Then Ken himself wrote me a letter saying, I'm the real guy. Then Ken's friend, who's here at this Congress, Scott, who's a very modest, great guy, went further and provided airtight evidence that this is truly the real Albert Most. So I made a mistake and identified the wrong person, but I don't think I would have ever found him if I didn't make that mistake. And I think that's true actually of a lot of these things relating to 5-MeO-DMT, is we've all made these mistakes, but it's been important to make them in order to learn the appropriate way to do things. Whether it's excessive harvesting of toad secretions, which we now are beginning to realize is not a sustainable practice, or charismatic traveling shamans who might manipulate participants in their ceremonies or do things that leave people traumatized or unhappy. I mean, nobody really knows what to do with this stuff, and so we have to learn from the mistakes that we've made in the past. I think that's one of the great difficulties with something that is new. I think that's one reason that we are so eager to assign some sort of indigenous history to this stuff, because it's uncomfortable to imagine that this is something that we brought into the world, that we are the first people to do this, and we have to construct our own culture surrounding it. And a lot of it's been bad so far. I mean, a lot of it has not been good, and it's only getting bigger. So I think now is really a great time as celebrities become increasingly interested, as more books are published, as more documentaries are made, to figure out how best to do this so that we can keep doing it into the future. And I think that's pretty much everything. Depending on how much time I have left, I can do some questions. Yeah? Time for questions, okay. Okay, cool.
With regards to the sustainability, like, what do you think's really the breaking point for the toads as far as their population and the increasing demand and popularity, the spreading of awareness, and what do we do when we reach that point, or are we already past that point, and who will provide that synthetic? Is that something that could feasibly be made in home labs, or, you know, like, what are we going to do when the venom runs out?
Yeah, I mean, I think it's good to start thinking about these things before it's too late. You know, it's good to begin before it's a problem. The issue is that there isn't a lot of formal study. I mean, imagine there's not even chemical analysis of the venom that has been published until this year, and that's pretty easy to do. When it comes to really labor-intensive things like monitoring population density of these toads, there's nobody really doing that. So it's going to require a lot of work to even evaluate how serious the habitat destruction is, how the numbers are declining. But I think that we should really seriously consider moving towards synthetic. And if the idea is synthetic doesn't replicate the natural material, then I would say, well, let's figure out what the difference is and synthesize that as well.
So I have a question about, you briefly mentioned the legality of the word derivative, or what derivative or analog means. And in the different controlled substances acts of different countries, talking about NN-DMT and their derivatives or analogs. And in some controlled substances acts, it'll say NN-DMT and their salts. So from a chemical perspective, what's the difference between their salts or their derivatives or analogs?
Right. So salt is actually a pretty clear word. Salt is a nice word. I have no objection to salt because, DMT and many of these compounds have a basic nitrogen. That nitrogen can be reacted with an acid and it produces what's called a salt. So this is a way of preventing people from saying, oh, you only made DMT illegal, but this isn't DMT, this is DMT fumarate, this is the fumarate salt, or this is the oxalate salt, or something like that. So that's pretty low-level stuff, and it has an explicit answer. What bothers me is when you can't answer the question because the word is so ambiguous that it has no chemical meaning, and that's the case for the word derivative. So if the word derivative means derived from, can you derive 5-MeO-DMT from DMT? It's never been done before. Is it possible? Maybe in some kind of elaborate synthetic scheme you could figure out a way to do it, but it's never been done. No one would ever want to do it. It's not a derivative in that sense of the word. And then if there's another sense of the word derivative, which is just any relationship, then who draws the line?
So are you saying that the salt, so 5-MeO-DMT would be a salt of NN-DMT?
No, definitely not.
Got it. Thank you.
All right, thank you. Just a couple of things. I just wanted to find out, are you saying that 5-MeO-DMT is not on Schedule 1?
It is in the United States
Yes,
as
okay.
of 2011.
So you're saying in Mexico, yeah.
It's
exactly.
not in Mexico, yeah.
So,
and a lot of the world.
And just a little thing on that, just to, I don't know, 1999, 2000 Mushroom Millennial Conference. Those of you that don't know who Sasha Shulgin is, I know that you know who Sasha Shulgin is. And that's the first time that I did the synthetic 5-MeO-DMT. And we all did 35 milligrams, which, nowadays, because we treated it like NN-DMT, which I did want to put an aside for here in this conference that everybody's been saying DMT, and everybody in the psychoanautical world knows that regular DMT is the NN-DMT, so please say 5-MeO when you express this. But
and to make things even more complicated, 5-MeO-DMT is also NN-DMT.
Yes, it's 5-MeO-NN-DMT.
Yeah, so it's really tricky there.
And the reason that 5-MeO became illegal in 2011 is because that's when people started putting their experiences on the internet, and parents started showing their congresspeople and all of that. So I also think we should be cautious about all the things that we put on the internet with what we're doing here at this time. And as you guys know, most of you, and I've been researching all of this because I'm going for claiming our rights here. But back to 1999 when we all did 35, and Sasha Shulgin was there, and after all of our experiences, which is a whole nother big story, I went to Sasha and I said, well, Sasha, what is the proper dose of 5-MeO-DMT? And he said, well, try 5, then do 10, and decide somewhere in the middle. And the next year when I saw him, I said, I like 14. And but then at that conference, somebody asked him in 1999, why is 5-MeO illegal? And then those of you that know what he looks like, he goes, well, God needed a loophole. 5-MeO-DMT is that loophole. That's the only way I can explain it. God needed a loophole, and 5-MeO-DMT is that loophole. And so we were using it quite a bit. There was a number of us until 2011, you could get it there. And then the other thing on bringing this about the synthetic, to make a kilogram of synthetic will... Yes. He and I talked a little bit about this earlier. So with a kilogram, that's 300,000 people. And so in doing that, so if what we need, and as you and I spoke also with the melatonin, our bodies make it from melatonin is my theory. And that's the easiest way to make it.
Yeah.
To make it there. And so do we need to just develop home ways of doing that?
That's basically what I was proposing. I wish I could have shown in a little bit more detail, but that's basically the idea. It's, yeah. Okay.
Yeah. Thank you.
So earlier you were talking about some of the other possible entourage elements. I think, let me see, N-methyl, serotonin, bufogenin, bufotolidin, 5-methoxytryptophan, 5-MIAA.
Uh-huh.
Have there been many studies done on exactly what these substances do in isolation and what they might do in conjunction to produce an entourage?
No, there have not been. But you can make an educated guess about quite a few of them that, based on everything that is currently known about the structure-activity relationship of tryptamines, that quite a few of them are extremely, extremely unlikely to have any serotonergic psychedelic effect. The indole acetic acid derivatives are probably biosynthetic precursors or something like that, or maybe they're just there. I mean, they would probably have activity in plants, but in humans, I think there's no reason to believe that. Some of the other ones, bufotenine is active, bufoviridine maybe, but I think it would depend on the sulfate group being metabolically cleaved. It's very polar. Bufotenine is already so polar that it was traditionally considered something that couldn't even enter the brain, and this is even more polar than that. So I would say that there's not a lot of strong candidates.
Are there any particular substances out there that would be the most likely candidate for entourage elements?
No, I would say that it's most likely the case that this effect is a 5-MeO DMT mediated effect for all intents and purposes. That whatever contribution the bufotenine makes, if it's even there at all, because the analysis is contradictory on that matter, is minuscule, back to the habanero pepper analogy that I made.
Hi. First of all, I want to thank you for addressing this very important topic because I work with both synthetic and Bufo 5-MeO DMT. I had a sample of Bufo analyzed by Paul Daly, who inherited Sasha's lab, and he found trace amounts of bufotenine and other tryptamines in there, but the major peak was 5-MeO DMT. Now, I've looked at the acute effects on the EEG and compared them, and they share a lot of similarities. I wanted to check that the Bufo produces the effects that the synthetic produces. However, there's a qualitative difference, and I think there's people in this room that would agree with that. Smoking the toad is different than smoking the synthetic. It has a different feel to it. The toad seems to last a little longer, take a little longer to come back. So there's something else in there in the mix that distinguishes these two.
Well, I don't doubt.
Have you had that experience?
Yes, actually, I have had that experience, but I wouldn't assign the experienced differences to chemical differences without a reason to do so. So I think that it would be more likely, if I had to guess, that it's a dosage difference. That because, like I was showing earlier, there can be a tremendous degree of variation in the potency between different batches of Bufo alvarius venom. It could be the case that 15 milligrams of synthetic 5-MeO DMT is not comparable to 100 milligrams of the venom with the assumption that it's 15%.
Yeah. In my work, I've hooked up a subject that wanted to take very strong doses, and we went as high as 100 milligrams of Bufo and added a pinch of synthetic to that. He survived it fine. He's a pretty strong guy. And what it does is it just magnifies the effect. It doesn't produce any additional effect. So, I work with medium doses of Bufo because I've seen what strong doses can do to people. And typically 30, 40 milligrams is my sample, and the effects are very, very consistent from person to person. I've done about 29 subjects now. And some of this is written up, and I'm working on a major paper to publish. Yeah.
Cool.
Yes.
Hi, Hamilton. My name's Scott, and I've actually known Ken for 35 years, the guy who wrote the book Under Albert Most. And when I heard you were speaking, had a whole list of questions for you. And I was going to, do you still believe Savinelli? And all I have to say is thank you for setting the record straight. I truly appreciate it.
Yes, and give it up for Scott, because because he's a very modest man, but he really helped me understand all of this, and I couldn't have done it without him. And also, Ken, the person who really did this, is going through some serious health problems right now. So I hope in the future to maybe figure out a way to raise a little bit of money for him, maybe by selling, the T-shirts that he designed with his friends when he first published his pamphlet, and using the money to help pay for his medical bills, because he did a really great thing for everybody, and it's sad that it never took any credit for it. And then two other people took credit for it who weren't him.
I was just curious to know, with all the research going into the science and what I'm listening to about your chemical versus from the frog, are we considering that the difference here may be a spirit of a toad that's actually at play here? And if that is the case, is it possible to ever actually synthesize that in the first place?
Right. Yeah, I'm just, for whatever reason, I'm totally 100% non-spiritual. So I do believe that there is no difference between synthetically produced 5-MeO DMT and 5-MeO-DMT isolated from the secretions of Bufo alvarius. And Erspamer himself came to the same conclusion. He compared a synthetic reference to the isolated 5-MeO-DMT. They're physically identical, the same melting point, the same boiling point, the same behavior in terms of chromatography. They're the same chemical. But I think that we often underestimate our own contribution to these experiences. So we tend to assign it to the drug, but not to ourselves. And there's something important and interesting and valuable about something coming from a toad. It's very strange. And that, maybe not in a spiritual sense for me at least, but just in a good old-fashioned psychological sense, will change things to know that this came from a living organism, that it was a defensive material that they created as opposed to something that was made in a laboratory in China or wherever. It changes things without any kind of necessarily supernatural overlay. Okay, thanks everybody.